We left off by establishing what are the critical preconditions and prerequisites for an effective ecosystem of e-governance. In this video, we want to go further and explore how far has Estonia evolved in terms of its e-governance ecosystem, given the precondition that it has met. So the question is, we're going to use empirical data that comes from the central log of X-Road, and we're going to describe the diffusion, how many services there are currently provided online, by how many institutions, by using how many data repositories, and ultimately, what is the amount of traffic or interactions they are producing. So for this purpose, we are going to be using a population-level data set that comes from the State System Information Authority, that is the governance agency in charge of running and maintaining the X-Road. And this entails just about the vast majority, if not, it's basically almost the entire traffic that is going on in the ecosystem of Estonian e-governance. It is a very large data set. It contains more than 2.5 billion observations, and it goes back all the way to 2002 for the data, the date from which we can start thinking about Estonia as a country with an effective e-governance. So there are two topics I want to cover. One is how many services there are, how many institutions there are in the ecosystem actively participating, and how many data repositories are being used. And ultimately, we're going to look at the traffic, what we call the bloodstream of Estonian e-governance ecosystem. So how many services and institutions and data repositories there are available in Estonia? We have here, for technical reasons, data coming from 2003 up until 2015. And what you see on a y-axis is the absolute number. Now, the light blue line over here shows you the amount of services. And you see that it has grown rapidly from almost zero to more than 1,600 e-services in 2015. The amount of institutions has grown at a little bit of modest rate to about 1,000. As a reference point, there are about 3,000, give or take, public institutions available in Estonia. Some of the institutions here are also private companies like Energy, Estonian Energy, or telecoms, or the sort of companies, the larger ones. And the amount of data repositories has grown to about 200 by 2015. Now, it is important to understand that here we don't talk about small little databases that are run for, I don't know, some operational benefit of an organization. Here we talk about registries. Large registries like population register, vehicle register, and so on, that are basically vital to provide public services for the entire population. Now, based on these data, what we can already tell you is that the average growth rates for these three services have been respectively about 123 e-services have, on average, have been added to the population of e-services over time on an annual basis. About 73 institutions have joined the X-Road on average throughout the period that we're currently looking at, and about 14 data repositories per year have joined the X-Road. So this gives us some anchoring points or kind of basic fundamentals of what it is or how big the Estonian e-governance system is. But now coming to perhaps a little bit more interesting part is the question about how much traffic it has actually generated. In other words, how frequently the e-governance ecosystem is actually being used. And what you see here is a graph for the same time period from 2003 up until to 2015. And on the y-axis, you have the amount of queries that have gone through X-Road in millions. So you see that in 2015, the amount of queries is just shy of 600 million a year. So this is in a country of 1.3 million people quite considerable, well above 1 million a day. So this is quite large. There is, of course, one qualification very important to make here, and that is that about 1/3, it is estimated, there is no clear knowledge about that, but about 1/3 of those queries are kind of due to the communication between two individuals, two humans, if you like. And about 2/3 are the machine-machine interactions. And what it means, what is a particularly machine-machine interaction in this particular case? It is, for example, if I, as some registry owner, will build an automated query that goes to another registry to check whether there are new entries that I should be able to know, that I should know for my basic business process. Like, for example, an insurance registry wants to know whether there are any new license plates issued. So I build a robot that basically goes every 2 seconds or every morning and checks whether are there new license plates? No. Are there now? No. No. Are there now new? No. So these are kind of build up the amount of interactions. And that's why it's important to distinguish between what's human to human and what's machine to machine. And it is 1/3 that is estimated to occur between two humans. So this brings us now to a very interesting question about the impact. How can we figure out, or can we use these data to show, however implicitly, the impact that Estonian e-governance ecosystem has had on its users? And I'd like to start off by this graph by just separating the amount of total interactions, which you see in the top line, that is actually kind of build up of the two following lines, the gray one, which shows the machine-to-machine interactions, and then the dark blue, the human interactions. So the question here is, let's first take those that only take place between individuals. And let's, for the sake of an argument, assume that every one of these human-to-human interactions have saved about 15 minutes of the two interacting persons. So why 15? Now think about when I have to interact with the government. There is an abundance of time that is required from me. I have to know whom to contact. I have to figure it out. I have to find the contact information. I have to call somebody in the office, fix an appointment, go there, do my thing, and get back home. So, 15 minutes is a fairly conservative assumption. And that even entails basically two persons. So let's just, for the sake of an argument, assume that every interaction between two humans, of those human-to-human interactions, have saved about 15 minutes. If we take the data that we have generated by X-Road, in total, about 47 million hours were saved. And that amounts to about 5,300 years of time cumulatively saved because of the availability of X-Road and the amount of public e-services that there are in Estonia. If you have difficulties in figuring out what the 5,300 years, how to meaningfully interpret that, then think of it as more than 5,000 people continuously working for 1 year. This is the cumulative amount of time that has been, at the best or at the minimum, saved by the Estonian e-governance ecosystem. Another interesting feature to which I would like to draw your attention to is the rate of diffusion. That is the pace of the takeoff of e-government. I will try to make an argument and support this argument with the population level data that diffusion of innovations and the diffusion of e-governance does not happen overnight, because the services that form the basis of any government ecosystem need to be built, and the data repositories that are really the nucleus of any functioning e-government need to be connected to the ecosystem in the first place. So let's use this data and see the relationship between the growth of queries and amount of services. For this, however, we're going to use the same data set, but we're going to go on the disaggregated level, where instead of years, we have observations changing on a monthly basis. And what you see here, on a y-axis, you have still the amount of queries, the interactions, the bloodstream of Estonian e-governance. On the x-axis, you have the amount of services, ranging from 0 to about 1,800. And what you see from here clearly, and this is super important and one of the key features in the technology diffusion literature, is that if you start building services, you add one service, then the second one, the third one. Up until to 400 services, you can see that there is virtually no or almost very little change in the amount of queries produced. And we're talking about a massive number of services, 400. Now, go further, go to the 600th service. Still, there isn't much growth in terms of actual usage of Estonian e-government. And only after that, after reaching a certain tipping point, which appears to be somewhere between 600 to 800 e-services, the amount of queries starts to grow exponentially. If you look at the amount of data repositories and how they are related to the queries, we have the same graph where we now have replaced the x-axis with the amount of data repositories. You will see that you add yet another data repository to the ecosystem and nothing happens. Of course, this correlates strongly with the amount of services because, as told before, you can build services on the basis of these data repositories. But here, perhaps it is more pronounced, the rapid tipping point, somewhere between 60 to 80 data repositories, after which the amount of queries starts to exponentially grow, and it has clearly kind of reached some form of a ceiling effect at around 200 data repositories. So these are the main anchoring points that we have available from the X-Road central log data about the ecosystem of Estonian e-governments. And our next question is, can we harness these data and go even further? can we start forecasting of what is going to happen to the ecosystem, to the diffusion of various aspects of Estonian governance ecosystem in the future, say in the next 3 years? This is the question to which we're going to come in the next video.